go. Okay, so what we're looking at here, and I'm going to just go ahead and press yes here. We're looking at the beginning of proofs. And really, to be able to do a proof well, you have to know the theorems, you need to know how the statements work and lead from one to the next. So what we're going to do for the very beginning of proofs is we're going to use some statements that are actually conditionals, but you might not have looked at them as conditionals before. And we're going to see how these statements can be used to solve an equation, which is actually a proof format because you have one step leading to the next, leading to the next. So let's look at the properties, and in our own words, we're going to describe how to remember the property, which will allow us to use it effectively in a proof format. First property we have is the addition property of equality. The way that this is a conditional is because it says if you have an equation, then you can add the same number to both sides of the equation. Here's how you could look at it. You could look at it as if we have x minus 2 equals 6. How would you solve that? Add 2 to both sides, right? X is equal to 8. In your own words, how did you use that property? What did we do? How could we say this in our own words? What does the addition property allow you to do? You can add a number to both sides. That's all it is. So go ahead and write that in your own words. You don't have to use mine, but just use the idea. You can add a number to both sides of an equation and really without changing the equation, without changing the solution. Okay, let's look at the next one. The next one is the subtraction property of equality. Basically states if you have an equation, then you can subtract the same number to both sides. So let's take a look at an example of how it might look. You might have something, for example, like x plus 2 is equal to 6. How would you use that property? What would x equal? 4, because you knew that you could subtract a number to both sides of the equation without changing the actual solution, without changing the equation. So in your own words, write how you would remember that property. It's called, again, the subtraction property of equality. So in my own words, I would just say the subtraction property allows me to subtract the same number from both sides of an equation. So subtract same number. From both sides of the equation. Notice how it's still a conditional? It's a conditional because you have an if. You have an equation. You're using a property to help you reach the then. Then x equals 4. Okay, the next property is called the multiplication property of equality. Here's how you have used it in your past. You might have seen something like x divided by 2 is equal to 6. How have you used it? What would you do in that case? Multiply both sides by 2, and we would see that x is equal to 12. You have to be able to look at that step and recognize what property was being used. So you want to look at that and say, how can I, in my own words, represent how to remember that property? To me, God bless you. To me, it's just you can multiply. Same number from both sides of the equation. All right, the next property is the division property. You might have something like 6 times x equals 30. That's your if. If you have this equation, then what can you do using the division property? What would we do? Divide by 6, right? So then what would x equal in this case? 5. All you're doing in a proof is you're justifying what you did. In that case, you used the division property of equality. You have to know when you used it. What did I do? I can divide the same number to both sides of equation. It's a colon. I'm just describing what happened.
No, the other.
The 6?
Oh, it's a 6.
Sorry. Maybe I should zoom in a little bit.
Yeah. Okay,
Yeah, sorry. It's a 6. To both sides of equation. Okay, next property is the distributive property. It says for any real number a, b, and c, if you have a number on the outside, you can distribute. So here's how it would look. If you have something like this, where you have 2 times x plus 5, then what can you conclude? Then, yeah, that can be simplified to 2x plus 10. Now, you guys have been doing this so often. Oh, thank you. Thank you. That's perfect. Thank you. Is anybody looking for a Surface Pen, by the way? Did anybody maybe lose it? Sierra, did you leave it under your chair, maybe? Oh, well, here you go.
Wait, Sierra.
All right. Well, awesome. I'm glad that I got to. Okay, so looking at this, let me begin. And yes, you need to multiply the number on outside of parentheses to both terms. Now, you guys don't have to use my explanations. You just have to use something that would allow you to remember what property am I using in algebra that allows me to get to the next step. Okay, the next one is, this is called simplify, where technically we just often call it combine like terms. For any real numbers a, b, and x, if you have 2 numbers of x, like 2x plus 3x, you can combine the 2 plus 3 and just call that 5x. So this is what it will look like if you have something like 2x plus 3x. You could put the if before that. But you know what this equals. What does that equal? 5x. And that's why you see it in the format of 2 plus 3x. Because you guys just in your head are adding 5x. Andrew? Okay, so how do we describe this? How do we describe that to help us remember it? Any ideas? Add numbers if they have x with them. So you add numbers with, or we can say combine numbers, or add, or subtract. That's why I just say combine. Combine numbers with, and if you're being more technical, you could say with same base and same exponent. You combine the x's because they both had the same x, and they actually both are raised to the same power. They're both first power. So combine numbers with same base and exponent, and that's just called simplify. This is the one that some people really get tripped up on. Just because it's not really a property that you're doing to both sides of the equation, it's just called simplify. If you look at the properties, notice that all of these are property of equality, property of equality, property of equality. Just means it's a property that's done in an equation to both sides of the equation. Whereas simplify, it can be done on one side of the equation. Just means whenever you see like terms together, add them. Okay, we got a few more properties. Notice we're starting with the most helpful, and then we're going to lead to sometimes helpful but not often is used. This is only for the algebraic proofs, which is what we start with. The most helpful will be the ones you often use the most. Okay, the symmetric property says, if you have A equaling B, then you can reverse that statement. So for example, if I end in my equation with, let's say you'll see 2 equals x, we often don't see an equation ending with 2 equals x, so we use the symmetric property, but we kind of use it subconsciously. We'll say, oh, that means x equals 2. So in your own words, what are you doing? Just flipping the side of the, flipping the equation. And it doesn't affect the solution. Okay, looking at the next one. The next one's the reflexive property, which we don't use it a lot with algebraic proofs. We will use it a lot with geometric proofs, which we will be getting into. But it just says that the value of the number doesn't change. If you have x equals 6, or if you have 6, it's going to equal itself. So you would just, how would you describe that? A number equals its own value. And you'll see how that's more helpful in geometry proofs. A number is equal to itself. Yeah, that's really a property. But you'll see why it's necessary in geometry, because you'll have to say, you'll have to use it when it's shared in a diagram. So if you have an angle that's shared by two different pictures, you'll want to say that the angle equals the angle to help you prove that. But we'll get into that later. That's called the reflexive property. It's the way I remember this one is if you're looking in a mirror, you get your reflection. You equals you. You look in the mirror, you're going to get yourself back. So that's how I remember the reflexive property. Okay, two more, and then we'll take a look at how to use these in a proof. Transitive property. This is actually very similar to the law of syllogism, which we learned a few days prior. What it says is if you have something like x is equal to, or a equals b, and you know the value of b is equal to 2, a lot of you guys can just figure this out. What do you know a has to equal? 2, exactly. Then a is equal to 2. And that's the transitive property. Everybody has their own way to remember it. I just take a look at, I think of it as the law of syllogism, but you might want to add in your own words, how can I remember that? I think of the law of syllogism, but you might not remember the law of syllogism, so you'd maybe want to add in your own words what that would mean to you. Last one is using substitution. Here's how the substitution property would look maybe a little bit different. If you know that x is equal to the value of b plus 2, and you know that b is equal to 4, how could you use the substitution property? Yeah, then you'd plug it in. So then you know that x would equal 4 plus 2. So you could simplify x would equal 6. So in my opinion, substitution is just replacing a value. Replace a value. Okay, I am going to do 2 short proofs with you, and then we're going to be working with some proofs in our group that you guys are in. So let's do some short proofs together. Here's how a proof will look. You will have 2 columns, and you will have your statement on the left side and your reasoning on the right. And you're going to use all of these properties on the first page to help you walk from one line to the other. So let's do one together, and I think after we do one together, it'll just be a little bit more clear of how to complete these. Number 1 says solve. 48 is equal to 5 times quantity 2x minus 7 plus 3. It says justify each step. Note you may not use all the rows in the proof. So we're going to solve it on the statement side, and we're going to use the property that allows us to solve it for the reason side. Here's the beauty of proofs. The first line is always the same, and if you can remember this, you always get 1 point out of the proofs. The first line is what is the equation, or what is given to you. So on the first line, number 1, write the equation that's given to us. We have to solve, so we just write 48 is equal to 5 times quantity 2x minus 7 plus 3. Reason is always the same for line number 1. It's given to me. There's no rhyme or reason. It's just given to me. And I'm going to prove what I need to. Now, what do I need to prove in this case? I have to solve for x. So I have to go line by line, justify what allows me to go to the next step, to the next step, to the next step until I solve. This is an algebraic proof. So let's take a look at number 2. Number 2, what would you guys do next? Distribute the 5. So I have 48 is equal to, I'm going to distribute the 5, and I would get 10x minus what? 35 plus 3. Now the key in proofs is justify. Why could you do that? You guys actually said it. What property allows us to do that? Distributive. So number 2 is just the distributive. And then it's really called the property of equality because we're in an equation. But I'm just going to title or abbreviate that as POE, which stands for property of equality. Okay, let's go to line 3. Think about this equation. What would you guys do next in this? Simplify, yes. Awesome. Josh even said our reason for what he's doing. He's adding negative 35 plus 3. He's simplifying those two numbers. So I'm going to go ahead and do that, and I would have 48 is equal to 10x, and then negative 35 plus 3 would combine to be negative 32, right? And then, Josh, can I pick on you again? What was that reason? You said it. You said it would start with an S.
Simplify.
Simplify. That's all he did. Notice I don't have to write POE because it doesn't have to be done to both sides of the equation. It just means simplify. It can be done on one side. All right, let's take a look at number 4, the next thing. Somebody else tell me, what would you do next? Ethan? Awesome. Add 32 to 48. So if I add 32, I would get 80 is equal to 10x. What allowed Ethan to do that? What allowed him? Maybe look at the first page. What, Gabe? Addition. Yes, he did it. Addition, property of equality. So number 4 is the addition. Nice job. And I'm just going to say POE because he did it to both sides of the equation. So that's why you would say property of equality. We're so almost done, and you guys actually just did your first proof.
Hey.
Number 5, what would we do now to solve for x? Marion? Division property. What would we do? Divide by 10 and we would get x equals 8. Perfect. You could write 8 equals x, and then you could write x equals 8, and then you could say that you use the symmetric property. Awesome. That would be great. One thing Kyle's noticing is everyone doesn't have to have the same proof. Like maybe somebody wanted to add 35 first and then subtract 3 in order to solve for x. That's okay. There's not one size fits all. You just have to explain how did you get to each step. So number 5, I would go ahead and write that in. We use the division property of equality. Jonathan?
Doesn't x equal 7?
Should equal 8. I think if we tried to make it 7, we'd have 14 minus 7, which would give us 7. 5 times 7 is 35. 35 plus 3 wouldn't give us 38. It wouldn't give us 48. It would give us 38. So it would be 8 in this case. But it's always good to check. Always good to check. All right, let's try this next one. Solve 3x plus 4 equals 12x plus 2 minus 5x. All right, what are we going to write first? Yeah, the same statement. So write what we're solving. 3x plus 4 equals 12 times quantity x plus 2 minus 5x. And what's my reason? Given. Perfect. All right, number 2. What would you do next? Peyton? Distribute. Distribute that 12. So I'd have 3x plus 4 is equal to 12x plus 24 minus 5x. What's the reason that Peyton was allowed to do that? Distributive property. Perfect. So we'd say distributive Notice I don't say property of equality because I'm not looking at I'm not doing it to two sides. Or wait a minute, is it called the distributive property of equality or is it called? Distributive property of equality because we do it within an equation, I guess. Okay, so yeah, we can add POE. Just so you guys know, I am not very particular about POE. I just want to see, do you know the name of the property? Distribute it. So that would be fine for me. Kyle.
Like on a test, if you wrote POE,
That's fine. Totally fine. All right, number 3. What would we do next? Add 12x and negative 5x, right? So that would equal, what, 7x? Okay, so I have 3x plus 4 equals 7x plus 24. What allowed us to do that? Simplify. Can sometimes be the toughest to name just because we didn't do it to both sides of the equation. We just did it to one. But yeah, we simplified. All right, number 4. Now here's where your proof might change depending on what your partner's doing. Doesn't mean either of you are wrong. You just have to lead to a next step. Can someone raise their hand and tell me what would you do next? Peyton? Okay, so she would move the 4 over to the 24, which is great. So she would have 3x is equal to 7x plus 20. And then, Peyton, what allowed you to do that? You actually said it when you... Oh, no, you said move.
Subtraction.
Subtraction. Awesome.
Yo, I'm a G.
Subtraction. Property of equality. Because we're working in an equation. Number 5. Christian, can you stop talking?
Yeah.
Christian, actually, can you tell me what I would do next?
What?
What would you do next? You want to talk, so I want to help you talk here.
You would subtract the... No.
I mean, you could if you wanted.
Yeah, let's do that.
You would get what on one side of the equation? If I subtract 3x from 3x, what will I get on that side of the equation? 0. Okay, if I use Christian's way, I'm going to have to add more lines, but that's possible. Did anybody want to do in a different way where maybe we could use less lines? Kyle? Subtract 7x. Awesome. You know, your way would have worked too. I just would have created more lines. It's true. Your x is going to equal negative here. But what allowed Kyle, or even if you had used Christian's step, what would allow you to do that? Subtraction. Property of equality. And then finally, number 6. What would we do at the end here? Divide, yes. So we would have x is equal to negative 5. And what property allowed Christian to say that? Peyton? Division. That's exactly right. So that's our justification. That is our reason. See, guys, proofs aren't that bad, right?
No, they're easy.
They're not bad. Let's keep going.
I can get them, anyone can get them.
Let's keep going. All right, next statement. What are you going to start with?
The given.
Given. So I'm going to have x over 8.
Hey, we got fractions in this property.
Yeah, they're awesome. Plus 5 over 6 is equal to 2. What allowed us to say this? Given. Beautiful. Now, there were a few people who solved this type of an equation the first day of school. I'm trying to remember who it was. Hannah Phelps. I think you solved it, where you multiplied everything. What would you multiply this equation by? Sorry, not to throw you on the spot. You solved it in a way where you just multiplied by the least common denominator, right? So do you know, so Hannah's way, and I liked this way, that's why I want to use it. She multiplied the entire equation by the least common denominator. What would be the least common denominator, guys, between 8 and 6? 24. If we multiply this whole thing by 24, what I love about that is we can distribute that in and it'll get rid of all of those fractions, which some of you, as soon as you saw fractions, were like, ooh, I don't like this. Yeah. So let's do that. What is 24 divided by 8?
24 divided by 8.
3. So we're going to have 3x.
4.
Plus, what is 24 divided by 6? It's 4. What's 4 times 5? 20 is equal to, and then what's 24 times 2? 48. Do you see how we got rid of that? Now, Hannah used a property that you should all be able to look and refer to now. What property did she use which allowed her to do that? Well, be careful. She did it to both sides of the equation. What property allowed her to do that?
Distributive. Subtraction of this.
Multiplication, that's it. It just says if you have equation, you multiply to one side, you have to multiply it to the other. So yes, I'm going to go ahead and use her property that she used, multiplication. Property of equality. Awesome. Okay, I want you with your group to finish this proof off.
I know, I just changed it.
That would be fine. Remember how to distribute?
Yeah, I just want to write it down for me because I haven't done that.
But that's good that you saw it. Okay, guys, take a look here. I finished the rest in 2 steps. The subtraction property of equality allowed me to have 3x equals 28, and then the division property allowed me to say that x is equal to 28/3. And I should add POE here, property of equality. Like I said, I'm more concerned about that first name. Any questions on that? Okay, then let's do this last piece here. It says each of the following questions has the same solutions as 3 times quantity x plus 4 equals 7. Explain why by giving the name of one of the reasons we have discussed. Okay, here's our if part. This is our if part. If 3 times quantity x plus 4 equals 7, let's look at letter A. What would allow us to say that 3x plus 12 also equals 7? Hannah. Awesome. Distributive. So letter A, that property would be the distributive. Letter B. Using that same conditional, or using that same hypothesis, if 3 times quantity x plus 4 equals 7, what would allow us to say that that's the same thing as 6 times quantity x plus 4 equals 14? Noah?
Division.
Well, that would be if you divided to both sides, but how do we get from the number 3 to 6 and 7 to 14? Multiplication. Awesome. So that would be the multiplication. Multiplication property of equality. Okay, look at the original conditional. If we have 3 times quantity x plus 4 equals 7, what would allow us to say that this is the same thing as saying 3 times x plus 4 minus 5 equals 7, really, equals 2. Kyle? Subtraction. Awesome. Subtraction. Property of equality. Last but not least, what would allow us to say that if you have 3 times quantity x plus 4 equals 7, that it's equivalent to 7 equals 3 times quantity x plus 4? Look at your front page. You'll need that front page as you're working on homework tonight.
Symmetric.
Yes, thank you, Bo. Symmetric.
Hi, Bo.
Symmetric property.
I see you, Bo. Bo, yo.
All right.